So let us imagine a scenario where you try to implement this without having the done variable, which we have used. Basically, done equals to 1 and done equals to 0. The approach that we have used. Can we basically implement conditional variable just using these, or can we actually implement thread exit, thread underscore exit, and thread underscore join without using the conditional variable? Actually, not. And that is basically because if you, as we have multiple times, as we have said multiple times, um, you need to think about all possible, uh, basically interleaving of operations in the system. When you're doing parallel programming, you really need to think about, okay, what if my thread gets descheduled at this point? So suppose that before you call thread join, okay, before you call thread join, right after you create the thread, the processor, basically the scheduler, decides that now I am going to jump onto the new thread, the child thread that was just created. The child thread starts running, and you have a very large round robin quanta. So you basically run until the child thread exits. Okay, so the child thread in this case calls exit, starts running exit right away, uh, tries to basically release the condition, basically signal the condition variable, but you never call thread join anyway, right? So now you have released, or you have signaled, uh, basically you have signaled something, uh, you have signaled for a conditional variable that no one is waiting on, because thread underscore join was never called. And then exit exits, and then thread underscore join is called, and it waits forever. Okay, because, well, no one is going to signal thread underscore join now because it missed the signal already. Okay, so you have to really think about how the different interleaving of operations can mess up your logic. Okay, let us ask another question. Do we need a lock? Can we just use the variable done, the shared variable done, and the conditional, the conditional variable, and the signaling and the wait primitives? Again, the answer is no, because basically the parent calls thread underscore join first and checks if done is equal to 0. Then right before calling wait, it switches to the child. Okay, so again, your scheduler messes up and decides that now it's time for the child to run. Child runs, calls thread exit, sets done to 1, then calls the signal. Okay, but here is an issue. The signal is again, well, raised, or basically sent before you ever called thread wait, right? Before you ever called condition wait. So you can get stuck forever in this loop, or in this, it's a loop basically, because you'll wait forever for something that will never happen because you just missed the signal.